On this example, we're asked to find the asymptotes in the graph, this given function 5x, or f of x equals 5x over x squared minus 4. So let's start with the vertical asymptotes, and that's where the denominator equals 0. Asymptotes is where your domain doesn't exist, in other words. So since you can't divide by 0, we're going to say x squared minus 4 is equal to 0. And the way I saw this is I like to add 4 to both sides. We get x squared equals 4. And then I like to square root both sides. Remember, when you square root both sides, it's plus or minus. So we get x equals plus or minus 2. So that means your vertical asymptotes are x equals negative 2 and x equals positive 2. Now for your horizontal asymptotes, we're looking at the degrees. The degrees, the highest exponents on the top and on the bottom. So here on the numerator, the degree of the numerator is 1 and the degree of the denominator is 2. Since the numerator is less than the bottom, because 1 is less than 2, then y equals 0 is the horizontal asymptote. And since the top is less than the bottom, that means we can't have an oblique. It's only oblique if the top is 1 more than the bottom. So in this case, there are no oblique asymptotes. I had the word slant, but I think this book uses oblique, so we're going to use oblique. And now we're going to graph it. And as of right now, we know certain things. We know at 2 and x equals 2 and x equals negative 2, we have vertical asymptotes. Those are imaginary lines that the curve approaches but never intersects. And then we also know that the horizontal asymptote is y equals 0, which is the x-axis. So what I like to do, since we have a graphing calculator and we don't really need any more information, it's not asking for more information, I'm going to graph it. So I'm going to put the numerator in parentheses just to be safe, divided by the denominator in parentheses. That's x squared minus 4. Let me erase that so you can see it better. And graph. And so what this tells us is it gives us some information. It shows that it's approaching here and down there to look something like that. And then it goes through the x-axis and the y-axis at 0, 0, looks like. But approaches up here and down there. Remember, asymptotes help you graph because they approach them. They never cross through them. They may intersect the horizontal asymptote once, but most times they don't. And then up here, approaches. So that does give you a pretty good rough graph, a sketch graph of how it should look.